Okay, this thing's recording. Here's one video to cover all the answers for spot check 27. This one was another one where you had to analyze all the roots of the builder functions, and then you had to build a polynomial with the given characteristics. Again, the overall strategy is you have to look at all the builder functions you're given, and you have to analyze what kind of roots they have, what will affect the end behavior, and what specifically is each y-intercept. So to talk about the roots, you're either doing the zero product property, or you're factoring, or you're doing the discriminant, which is b squared minus 4ac. You're taking the square root of that in the quadratic formula. Okay, let's take a look at some of these. This one, the root is 0. This one, the root is -1 because of that negative. Here the root is 0, it's a double root. Here the root is -1. Here the root is +2 because of the zero product property, and so on and so forth. When you get to the squared part and you solve this x squared plus 1 equals 0, you're trying to find out what the x equals. When you subtract 1 to the other side and take the square root, aha, there's where you're looking at. If you're taking the square root of a negative, that means you're going to have two imaginary roots. So that's actually going to happen with function p, r, t, and w. T doesn't factor, so you go to the discriminant, and if you do b squared minus 4 times a times c, that's going to be a negative number. If the discriminant is negative, again, that's how you're going to have two imaginary roots. Okay? And then you continue going through and analyzing all the roots of the functions, and you have those in your hip pocket. And then the thing that's going to affect the end behavior are these negatives. Negatives as a leading coefficient is going to help make your right end behavior down if required. Last thing, the y-intercept. The y-intercept is when x equals 0. So let's look at these functions right here, for instance. If x equals 0 for function m, the y-intercept, its part is 3. For p, the y-intercept, its part is 1. Now you're going to build 2 or 3 functions together, and you're going to want to multiply these constants together to find the exact y-intercept. Now for this specific example, I need to have degree 6, so I want to make sure I have 6 x's in there somewhere. The end behavior is down, down. That makes sense because that's even, so the right end, the left end matches the right end. So I'm going to have either f or j or w in there. 4 imaginary roots, and that's if you found out the 4 imaginary roots, you say, okay, I know I have to have p, r, t, or w. 2 of those in there to get my 4 imaginary roots. And then 1 root specifically. When you go through the factoring or the zero product property on function s is actually factors using the magic x technique into +4 + 1. That means it breaks down to these two binomials, and then you can see the zero product property. There is a -4 right there, and that's -1 is the root. But you see, we're looking for a root at -4. So you know you have to have 2 of these imaginary roots. You know you have to have function s. The end behavior, I know I have to use function w. So I've nailed it down to function w and function s. The last thing is looking at -32 for the y-intercept. You go, okay, if I know I have to use w and s, -8 times 4 is -32, but I have to get 2 more x's in there because it needs to be degree 6. What if I multiply that times 1? Function p, and that's actually what we find out the answer in this case, w times s times p, to get all these requirements. So you have to do all this analysis on this one problem to all these functions. That's what makes this so difficult. And you have to make sure that the function you choose has all the reasons about each of the function, the polynomial behavior, to fit the polynomial we're trying to build. That's why this concept is so difficult, and that's why we've been practicing it so much. Just to explain real quick, the other 2 classes spot checks, this one was exactly the same. I just changed the y-intercept to -288. So instead of using p, you'd use function r. 8 times 4 times 9 is -288, or -8 I should say. And then lastly, for 4th period, same thing. I just changed the requirement for the y-intercept. You're still going to use w and s, but now we're multiplying by t, the 7, to get us up to the -224. That's it.